All right, we're back. Yep, been months, but we're moving on to hydraulics because it's actually more specific to the environmental exam. Math and probability and statistics, you can find those elsewhere. We're moving on to hydraulics. All right, so for our first question, we got the flow of water in a horizontal pipe of constant cross-section has a pressure gauge at location 1 with a pressure of 100 psi and a pressure gauge at location 2 with a pressure of 75 psi. What is the head loss between the two pressure gauges? All right, so first things first, we're dealing with pressurized pipe flow. So we're probably going to be having to use the energy equation in some form. I'm going to write that down. Okay, so here is our energy equation. Now, if we remember, we got pressure head, elevation head, velocity head, head supplied by pumps, and then we got the same on the other side. And then these final two terms, we got the head loss and head supplied by turbines. So now we want to check if we can cross any of these terms out. So first thing we know is that there aren't pumps in this question, so we can cross out that one. We also know there's no change in elevation, so we can cross out the elevation head terms. We also know that this is a constant cross section, which means that the velocity will be the same, so we can cross those out too. And finally, we know that there are no turbines, so we can cross out that one. So we're really simplifying this question. So now let's rearrange. All right, so now we're gonna be left with something like this. And now we know all the numbers, so we can just plug and chug. So this will be 100 psi minus 75 psi over the specific gravity of water, which in this case we're going to use 62.4 pounds per square foot. Now we know that the pressures are in pounds per square inch, so we need to convert that to pounds per square foot. So we'll add this conversion factor. Now we just calculate, and that'll get us about 57.7 feet of head loss. Okay, for our second problem, I got this silly little pipe system with some known pressures as well as the flow rate. And we want to determine first the head loss between locations 1 and 2. Now I got this split screen so you can have a constant view of what the pipe system looks like, and I'm going to solve it on the right side here. So again, we have pressurized pipe flow. We're going to use our energy equation. Now, this first part between 1 and 2 is going to look similar to our last example. It's a constant size pipe with constant flow, no elevation change, so we're going to have a pretty similar procedure to solve this part. So let me go ahead and write that. So here's our energy equation again, and again we have no pump, same size, no elevation change, and no turbine. So again, we're going to have head loss equal to pressure 1 minus pressure 2 over specific gravity of water. So we're going to have 14 kilopascals minus 12.5 kilopascals over, and now we're going to use 9.81 kilonewtons per meter cubed, which will give us a head loss of 0.153 meters. So yeah, very similar to the last part, or the last question. So now on to the second part of this question, is determine the head loss between 1 and 3. So it's going to be a little more complicated here. Okay, first step again, write our energy equation. All right, so for this part, we're going to look at our pipe system and our energy equation again. Can we cross out anything here? Well, yeah, we don't have pumps again, and we don't have a turbine. But for the rest, we have a changing, just point these out, changing diameter between 60 mils to 40. We have a change in elevation of 5 meters. So we're gonna have to keep those terms around this time. All right, so first step here is we don't know the velocity, but we do have the flow rate. So let's go ahead and convert or use our continuity equation, Q equals V times A, to find our velocity at point 1. So Q equals VA, can change that to V equals Q over A. So we're given an elevation change of 5 meters, so let's convert everything into meters. And we're given Q as liters per second, so there's 1,000 liters per cubic meter. So we're gonna divide that 7 liters per second here. We're gonna divide that by 1,000. So 7 divided by 1,000 up top here for our flow in cubic meters per second, divided by I times 60. We're going to convert that 60 mils to meters. 60 divided by 1,000 over 4. Don't forget that squared there. That'll give us a velocity of 2.477 meters per second at point 1. So if we do all the same things again with the 40 millimeters divided by 1,000, 40 divided by 1,000 over 4, you're gonna get a velocity of 5.385 meters per second at point, whoop, not 2, 3. So now we actually have everything we need. We have our pressures, we have the change in elevation, and we have our velocities. So now we can solve for head loss. Also, since I didn't mention before, we're going to use this line down here as our datum. So we'll say up here is 5 meters above the datum. This will be 0. Alright, so we'll have a big mess like this, and we can just plug and chug and solve for head loss. It'll give us about 4.24 meters of head loss through our simple type system.